Hello students, welcome back to EduRev. The topic we have picked today is matrices and determinants. We will be discussing some questions related to it. So let's dive into it. I have divided the questions into three types. The first one is from product of matrices, the second one is from Cramer's rule, and lastly, the third one is from properties of adjacent of a matrix, inverse of a matrix, and transpose of a matrix. So let's begin with type 1. So as I have told you, type 1 contains what? Product of a matrix. Product of a matrix. So let's see what is there in question number 1. So question number 1 states that alpha is a root of this equation, that is x squared plus x plus 1 equals to 0. And we have a matrix A. And we need to find what is a to the power 31. Now the equation which we have is x squared plus x plus 1 equal to 0. And we know that roots of this equation is omega and omega square. So let alpha be equal to omega and omega square. So what I'm going to do now is I'm going to substitute omega and omega square into matrix A. So it's simply going to be A equals to under root of 3 1 1 1 1 omega square and 1 omega square omega. Now the thing is that we need to find out that what is a square. I know that a square is nothing but a cross a. So we need to find out what is a cross a. So it's simply going to be 1 under root 3 into 1 1 1 1 omega square 1 omega square omega into 1 by root 3 into 1 1 1 1 omega square 1 omega square omega. So when I'm going to find this, it will simply come out as a square equals to 1 by 3 1 plus omega square 1 plus omega square 1 plus omega square 1 plus omega square and 3, and then finally as 1 plus omega square 3 and 1 plus omega square. Now do you people remember that 1 plus omega square equals to 0? So if I'm going to substitute this in this matrix will look a little bit more simpler. So let's substitute 1 plus omega square equals to 0 into this matrix. So a square will be what? A square will be equals to 1 0 0 0 0 1 and 0 1 0, since we know that 1 plus omega square is going to be 0. As simple as that. Alright. Now I want to find out a to the power 4. Now we know that a to the power 4 is nothing but a square cross a square. Now I know what is a square, so we can find what is a square cross a square. So it's simply going to be nothing but 1 0 0 0 0 1 0 1 0 into 1 0 0 0 0 1 0 1 0. So a to the power 4 is going to be what? A to the power 4 is going to be, so now first of all, how to calculate this matrix? Let's see, okay? If you people do not know, then do not worry. Let's see how to solve it. So the thing is, to find the first place, I need to multiply and add this. That is 1 into 1 is 1. Then 0 0 plus 0 and 0 0 plus 0. So it will be what? It will be 1. Similarly for this, like this position, I have to multiply this row with this column, and for the third position I need to multiply this row with the third column. So similarly the answer which I'll get is 1 0 0, and similarly I need to do for other rows. That is, it will be 0 1 0 0 0 1, and finally this will be equal to I. Now let's suppose, because I have multiplied, so let's suppose this is I1, this is I2, so let me take it as I3. So now the thing is that we know that a to the power 31 is nothing but it is a to the power 28 times a to the power 3, correct? And a 28 into a to the power 3 is going to be nothing but a to the power 3. So this is nothing, but I know that in my question we were asked that what is going to be a to the power 31. So a to the power 31 is not nothing but what? A to the power 3, and that is the answer. I hope you people understood it. Now let's move on to next question. So next question states that if A is given, then I need to find the matrix that is a to the power minus 50, where theta is pi by 12. Now the thing is that A is given, right? And I need to calculate what is mod of A. Now if you do not remember that, do not worry. Mod of A is nothing but I need to multiply this, that is cos square theta minus, and then multiply this, which is going to be negative of sine square theta. So I know that negative will be addition, that is cos square theta plus sine square theta. And we all know that cos square theta plus sine square theta is going to be what? 1. Therefore, mod of A is going to be what? 1. Now we need to find that what is adjoint of A. Correct. Now adjoint of A is written as cos theta minus sine theta, cos theta to the power t, and this is how it is written. And when I'm going to solve it, it will be nothing but cos theta sine theta minus sine theta, actually, because the sign is going to change, then sine theta and cos theta. Now I need to find that what is the inverse of A. So remember that inverse of any matrix is nothing but adjoint of that matrix upon mod of that matrix. But in our case, the mod of that matrix came out to be 1 as we calculated. Therefore, I would say that inverse of the matrix that is given to me equals to the adjoint of the same matrix. So obviously, if I know the adjoint of a matrix, I also know the inverse of that matrix. Correct? So inverse of that matrix is going to be nothing but it's going to be cos theta sine theta minus sine theta and cos theta. Simple. Now let's suppose that A inverse is nothing but B. I have done nothing but just changed the name of the matrix and I've just called it B. Now we need to find out that what is B square. Now again we know that B square is nothing but B cross B. So if I need to find that, I simply have to write cos theta minus sine theta, cos theta, and I have to repeat it again, right? Because we are multiplying B with B. So cos theta sine theta minus sine theta, cos theta. Correct? So now I need to find out what is B square. So remember that when I want to find out the first place, as I've told you in the previous question, then I have to multiply and add this with this, that is first row with first column. So it's going to be nothing. It's going to be cos square minus, cos square into cos square, then add sine square into minus sine square. And similarly, all these additions are going to happen. So when we are going to apply the trigonometric identities, then we can solve it even further. And if I'm going to write the refined terms of these trigonometric properties, I would write that B square is nothing but B square is cos 2 theta minus sine 2 theta, sine 2 theta, and finally cos 2 theta. So I know what is B square, right? Now simply to find B3, I know I have to do B square into B, correct? That is, I have to multiply this matrix with this matrix, correct? So I'm going to leave the calculations to you. I'll just tell you that what is B cube. So B cube will be cos cube theta minus sine cube theta, sine cube theta, cos cube theta. But wait a minute. Can you see something like a form of pattern? Yeah, for sure. The thing is that when I was writing only B, theta was only theta. When I calculated B square, theta became 2 theta. And when I calculated B cube, theta became 3 theta. This means what? This means as I'm raising my power of B, theta is also multiplied by that number. So similarly, by observing the pattern, can I write that what is going to be A to the power minus 50? Now I know that inverse of this is going to be B to the power 50. So I can write what is b to the power 50, and similarly on that terms only I can find that what is a to the power minus 50. So b to the power minus 50 is going to be nothing but cos 50 theta minus sine 50 theta sine 50 theta and cos 50 theta. So this is going to be b to the power 50. Now the thing is that theta is nothing but theta is pi by 12. So if I am going to put pi by 12 into this, I can easily find the matrix. So to find the matrix, I would write root 3 by 2, half, minus half and root 3 by 2. Simple. Why? Because we know that cos 50 pi by 12 will be equal to nothing. I'll just write it down. Okay. So I know that cos 50 pi by 12 is going to be equal to cos of 4 pi plus pi by 6, which will be equal to cos of pi by 6, which is nothing but root 3 by 2. Similarly, as I have calculated root 3 by 2, I'll calculate all the other values. So my answer is going to be this matrix. So going back, the answer has to be root 3 by 2, then minus half. So this is the answer, that is root 3 by 2 minus half, 1 by 2 and root 3 by 2. So I hope you understood this. Alright, so let's start with type 2. Now type 2 consists of Cramer's rule. So before moving forward with the question, let's understand what is Cramer's rule. So in Cramer's rule, we need to find the delta, that is the determinant of a matrix. Now let's suppose we have three equations, a1x plus b1y plus c1z equals to d1, and similarly a2x plus b2y plus c2z equals to d2, then a3x plus b3y plus c3z equals to d3. Now I need to find the solutions of these three equations. So to find the solutions of these three equations, let's form a matrix, and that will be a1, a2, a3, b1, b2, b3 and c1, c2, c3. So this matrix is termed as the determinant. But now what is determinant 1, determinant 2 and determinant 3? So determinant 1 will be when I am going to replace a1, a2, a3 with d1, d2, d3, that is determinant 1. Determinant 2 will be when I am going to replace b1, b2, b3 with d1, d2, d3. And similarly determinant 3 will be when I am replacing c1, c2, c3 with d1, d2, d3. So we know what is determinant 1, 2 and 3. Now the thing is that if I solved this matrix and this matrix came out to be non-zero, because obviously if I'm finding any solution, either it's going to be 0 or it's going to be non-zero. So let's consider that that determinant is non-zero. In that case, if that determinant is not 0, then we have consistent system. And consistent system means we have one unique solution. So when we have one unique solution, x is going to be determinant 1 by determinant, y will be determinant 2 by determinant and z will be determinant 3 by determinant respectively. Now the thing is that suppose we find out that it's determinant and we got determinant equals to 0. In that case, we need to check delta 1, delta 2 and delta 3. Now there can be two possibilities. Either delta 1, delta 2, delta 3 all are equal and they are equal to 0. In this case, what can happen that we will get infinite number of solutions. Whereas, when at least one of delta 1, delta 2 and delta 3 are non-zero, in that case, we will get inconsistent system. So therefore, whenever we check the determinant, we need to see that whether that is equal to 0 or not equal to 0. When it's not equal to 0, we will simply have a unique solution. When it is equal to 0, then we need to check out the values of determinant 1, 2 and 3. When all the values are equal and they are equal to 0, then we will have infinite solution. Whereas when at least one of them will be non-zero, we will have inconsistent system. Now the thing is that suppose your D1, D2, D3 in these three equations are 0. So when D1, D2, D3 are 0, then delta 1, delta 2, delta 3 will also be what? 0. In that case, these equations are termed as what? Homogeneous. So this is basically what is Cramer's rule, in which we find out the value of determinant 1, 2 and 3. And this will help you to solve so many questions in simpler ways. So let's move on to question 1 for Cramer's rule. The question says that we have a system of these three linear equations where ABC belongs to real number and they are non-zero and distinct, and they also have a non-zero solution. Then which of these are true? Now the thing is that because D1, D2, D3 are 0, as you can see in these equations, that means delta 1, delta 2 and delta 3 are 0. Now the thing is that x equals to delta 1 by delta, similarly y equals to delta 2 by delta, and z equals to delta 3 by delta. Now the point is that when delta 1, delta 2 and delta 3 are 0, that means x, y and z are what? They are also 0. That means we have a unique solution, which is what? 0, 0, 0. But in the question they are saying that we have a non-zero solution, and this is only possible when the determinant is also 0, because at that point the solution will be what? They will be infinite. So we just need to convert this determinant into 0, and for that, when that criteria will be met, ABC will occur in form of a series, and we just need to figure out that whether it's AP or GP or whatever. So if I create a determinant, then it will be simply 2, 2A and A, 2, 3B and B, 2, 4C and C. And this is determinant of the equations that are provided, as I'm underlining, you can see. Now the thing is that to convert it into 0, what I'm going to do, can I apply R2? Can I write R2 as R2 minus R1? Similarly, R3 as R3 minus R1, correct? So if I'm going to do this, then what is going to happen? It will be 1, 0, 0, 2A, 3B minus 2A, 4C minus 2A, A, B minus A and C minus A. And this should be equal to what? This should be equal to 0. Now when I'm going to solve this, I can say that 1 into this times this, that is this times this means 3B minus 2A times C minus A, minus B minus A times 4C minus 2A, that is this. Alright, so when this is happening and this is equal to 0, so when I'm going to solve it, just a minute, yes. So when I'm going to solve this equation, that is 3B minus 2A into C minus A minus B minus A into 4C minus 2A equal to 0. So it will be 2AC equals to BC plus AB. So that will be 2 by B equals to 1 by A plus 1 by B. Hence 1 by A, 1 by B and 1 by C is in AP. I hope you understood this. Let's move on to next question. Alright, so the next question states that this is the following set of linear equations that is given to us, and we need to find out which of the following is true. Now to solve this, can we see that D1, D2, D3 in these equations are 0? This signifies what? This tells that delta 1 is 0, delta 2 is 0 and delta 3 is also 0. Now if I want to find out delta, so I will simply write what? I will make the coefficient matrix, that is 7, 3, 1, 6, 4, minus 2, minus 2, 2 and minus 6. So when I am solving this, I will write 7 into minus 24 plus 4 minus 6 minus 18 minus 2 into 6 minus 4. That is what I've done. I've written 7, then this multiplied by this minus this multiplied by this, then 6, this multiplied by this minus this multiplied by this, and then minus 2, this multiplied by this, that is 3 times 2 minus 4 times 1. And when we are going to solve this, we will get what? We will get that delta is also 0 because this is going to be minus 140 plus 120 plus 20. So all of this has to be equal to 0. So we know that delta is 0, we know that delta 1, delta 2 and delta 3 are equal to 0. Hence, for the given system of equations, infinite many solutions are possible. Correct? So infinite solutions are possible for it. Now, from equations 1 and 2, let's suppose this equation be 1, this be 2 and this be 3. So when I am handling equation 1 and 3, actually not 1 and 2 but 1 and 3. So when I am handling equation 1 and equation 3, and if I am solving it, so can I write that 7x plus 6y minus 2z plus 3 times x minus 2y minus 6z equals to 0. That is x equals to 2z. So x is equal to 2z, that is option number 3. Infinitely many solutions possible, that is x equals to 2z. Let's move on to the next question now. And next question will be of type 3. So do you people remember what is type 3? Type 3 questions are going to be questions that are related to, as I've told you, adjacent of a matrix, then inverse, and finally transpose. So let's begin with question 1 of type 3. So let's start with next question, that is question 5. Now in this question we are given this matrix, that is matrix A, and we need to find out that whether it's invertible or not invertible. Now to find out whether a matrix is invertible or not invertible, we have to find the determinant of that matrix, and then we need to figure out that whether this determinant is equal to or not equal to 0. Alright, so if it's not equal to 0, then the matrix is said to be invertible, and if it is equal to 0, then it is not invertible. So let's find out the determinant of matrix A and see whether it's invertible or not invertible. And if it's invertible, then for what values of R is it invertible? So now we know that determinant of A will be what? It will be this. That is mod A. So I need to write what? E to the power T, E to the power T, E to the power T, cos T minus E to the power minus T, cos T E to the power minus T sin T and 2e to the power minus T sin T. Then last e minus T sin T minus e minus T sin T plus e to the power minus T cos T, and finally minus 2e to the power minus T cos T. Now the thing is that you can see here that e to the power T is common to this, right? Whereas e to the power minus T is common to all of it. Correct? Whereas in the last row, e to the power minus T is again common. Right? So that means from this, I can take e to the power T as common. From this, I can take e to the power minus T as common. And from the last as well, I can take e to the power minus T as common. So when I take them out, I'll write e to the power T into e to the power minus T into e to the power minus T. So the remaining will be what? The remaining will be 1, 1, 1 cos t sin t, then minus of cos t minus of sin t, then 2 sin t, and minus sin t plus cos t, and finally minus 2 cos t. Now to find what is the value of this determinant, can I say R1 can be written as R1 minus R2, and R2 can be written as R2 plus R3. Now I am doing these two so as to make these two places as 0, because if two of these places are 0, then calculating the determinant would be very easy, because here we have 1. So we only have to like multiply and subtract these two. So I just have to multiply these, then subtract, and then multiply these two, correct? So it will be very easy to calculate this. So if I am doing these two operations on this determinant, then my determinant would be what? It will be e to the power minus t, because this and this will get cancelled. So e to the power minus t is left. So it will be 0, 0, 1 minus 5 sin t. It will actually be 2 cos t sin t. So this will be what? It will be 2 cos t plus sin t, right? Then we will be having minus cos t minus 3 sin t and 2 sin t. Last column we will write 2 sin t minus cos t, then minus sin t plus 3 cos t and minus 2 cos t. Now, can I write R1 as R1 plus 2R2? Alright, so if I am going to do this operation on this, R1 will be what? R1 will be, so it will be 0, 0, 1 minus 5 sin t, right? Then minus cos t minus 3 sin t and 2 sin t. Similarly here I can write 5 cos t minus sin t plus 3 cos t minus 2 cos t. Correct. So now what I have to do, I need to figure out what is the value of this determinant. So this is 0, 0. So I just need to figure out with 1. So if I'm going to do that, I just have to multiply this with this, then subtract and multiply this with this. That is it, right? So let's find out how to do this. Okay. So when I apply that operation, I'll write e to the power minus t into minus 5 sin t minus 5 sin t into minus sin t plus 3 cos t. Right? Then negative of minus of what? 5 cos t into minus cos t minus 3 sin t. And when I solve all of it, wait a minute. So, when I solve all of this, what will happen? The answer will be 5 e to the power minus t. Now we can simply see that this value does not depend upon any theta, correct? And as e to the power minus t cannot be equal to 0, so we can say that this whole thing cannot be equal to 0, correct? That means A is what? A is invertible, as determinant of A is not equal to 0 and A is invertible for all values of t that it belongs to real numbers. So the correct option is going to be option number A. That means it is invertible for all t belonging to real numbers. So I hope you understood this. Let's move on to the next question. Alright, so the next question is that if A is this, we need to find the minimum value of determinant A by B where B is greater than 0. Now in these types of questions where we need to figure out the minimum value of something, then usually we use the property of AM greater or equal to GM. Do not worry if you do not know what this property is. Let's figure it out side by side while solving this question. So we know that what the matrix is, right? So let's find out the determinant of this matrix. So the determinant of this matrix will be 2b1, b, b square plus 1, b, then 1, b, 2. So it will be 2 into b square plus 1 minus b square whole 2. And then it will be minus b times 2b minus b plus 1 times b square minus b square minus 1. Now how did we find this? What we need to do is we need to write the 2 here, and then forgetting that this row and this column exist, we need to multiply this by this and then subtract and then multiply this by this. And then we need to do it exactly the same thing for b and for 1. And because of that property, we find out what is this. So when I'm going to solve it, it will be 2b square plus 4 minus b square minus 1, that is b square plus 3. Now mod A by B will be what? We know that mod A is this, but we want to find out this, right? So mod A by B will be b square plus 3 by B, right? Which is going to be what? B plus 3 by B. Now we need to figure out the minimum value. So we need to use the concept of AM greater than GM. Now in this case, what we are going to do, we need to find out AM greater or equal to GM. The two values which we had, basically the value which we had was b plus 3 by B. So AM will be b plus 3 by B upon 2, which should be greater or equal to b into 3 by B 1 by 2. This will be b plus 3 by B greater or equal to 2 will go to that side, 2 times root 3. So mod A by B is what? Greater or equal to 2 root 3. That is the minimum value of mod A by B is going to be what? Now mod A by B is greater or equal to 2 by 3. So that means it cannot be less than 2 by 3. That means the minimum value which mod A by B needs to take is what? 2 root 3. So the minimum value is going to be what? 2 root 3. So I hope you people understood how to solve this question, and I hope the concept of matrices and determinants is clear to you. Now you can go to EduRev and you can find more amazing content regarding matrices and determinants, docs, videos and tests. You can also unlock the logged videos and the content by purchasing EduRev Infinity Plan and ace your exam at less than 80 rupees per month. Thank you.